Hi, I'm Kumar. In this module, I'm going to explain everything about RISCv. I will address all your questions: why, what, and how. Why do we need RISCv as an open ISA? What is RISCv? How did we adopt RISCv so far? The RISCv adoption. Also in this module, let's explore the RISCv ISA. RISCv ISA defines various things like unprivileged architecture and privileged architecture. As part of unprivileged architecture, it defines various things like registers. Overall, there are 32 general purpose registers. There is a special register called program counter. It also defines base ISA. There are 40 instructions, and it also defines various standard extensions, and user can also add their own extensions. As part of privileged architecture, RISCv defines various layers like machine ISA, supervisor ISA, and the hypervisor extension. Also, RISCv provides various interfaces like ABI, Application Binary Interface, for the application to interface with AEE, Application Execution Environment, and SBI, Supervisor Binary Interface, for the operating system to interface with the SEE, Supervisor Execution Environment, and HBI, Hypervisor Binary Interface, for the hypervisor to interface with HEE, Hypervisor Execution Environment. So let's explore the RISCv ISA. RISCv originated as a small project at UC Berkeley in 2010. RISCv means fifth major ISA. RISC means reduced instruction set computer, and Phi means fifth major ISA, instruction set architecture. RISCv is a license-free open ISA. You can download the specification from the website riscv.org, and you can implement your processor as you prefer. You can also contribute your design back to the community as an open source IP. Using RISCv, you can realize all kinds of computing systems like from microcontrollers to supercomputers. RISCv is not a company. RISCv is not a CPU implementation. It's an ISA, instruction set architecture. RISCv International is a non-profit organization. RISCv International maintains the RISCv instruction set architecture, all the specifications. Also, it manages the stakeholder community. There are more than 3,900 RISCv members across various countries. You can download the specifications from the website riscv.org. There are various kinds of specifications that define unprivileged architecture and privileged architecture. And there are other specifications to deal with various things like off-chip debugging or interfacing with interrupts. So there are specifications for debug architecture. There are specifications to implement platform-level interrupt controller, primarily to interface with various kinds of external interrupts. You can visit the website riscv.org and download all the specifications. Why do we need RISCv as an open ISA? OEMs, original equipment manufacturers like Apple, design various kinds of complex SoCs. SoCs like A-series chips and M-series chips. These SoCs use various kinds of processors. They need CPUs, could be RISC and CISC. Apple uses RISC processor even for their desktops. Now, we are exploring how to use a RISC for everything. Apple uses RISC, reduced instruction set computer, even for their desktop. Now, we are exploring how to use a RISC for everything from smartphone to desktop to cloud servers. So, we need CPUs, RISC CPUs, GPUs, graphics processors, ML accelerators, application processors, image processors, DSPs, radio DSPs and audio DSPs, digital signal processors. There could be various security and neural engines, and we need processors for the power management. So like this, there could be various kinds of processors. All these processors could be based on general purpose and specialized ISAs. We have no problem with general purpose ISAs, but when it comes to using specialized ISAs, we need to understand how to deal with various kinds of challenges associated with these specialized ISAs. Also, each ISA comes along with unique software stack. So let's look at the challenges we face when it comes to using specialized processors. Specialized processors depend on special purpose ISAs. So in this case, we need to work with multiple IP vendors. Different IP vendors may have different IP licensing schemes, and the engineers will not have the freedom to customize the ISAs. All specialized ISAs will not survive for long. Also, the software or application development and updates involving multiple ISAs and tool chains would be very, very challenging. That's where RISCv offers an open ISA like this. You can think of using RISCv OpenISA to implement all kinds of processors. That's how RISCv ISA is going to emerge. It's going to emerge as an industry standard ISA for all kinds of processors. Whether you want to implement CPUs or GPUs or DSPs or neural engines or accelerators, you can think of using RISCv ISA for everything. As I mentioned, there are various general purpose and special purpose ISAs. So it's very obvious that general purpose ISAs survive for decades. IBM processor for more than 50 years, Intel's x86 for more than 40 years, ARM for more than 30 years, and RISCv is continuing for more than 10 years. But when it comes to special purpose ISAs, we need to really understand they don't survive for decades. Also, let's compare RISCv ISA with x86 and ARM. You can understand the advantages of RISCv ISA. Are there chips available implemented using general purpose ISAs? For x86, yes, there are some vendors. For ARM, there are many vendors. And RISCv, similar to ARM, there are many vendors in the ecosystem. x86, whether it offers architecture license? No. ARM, yes, but very expensive. RISCv, it's open ISA. You can customize the ISA as you prefer. You can think of adding your own instructions. Are there commercial IPs available in the ecosystem? For x86, no. For ARM, yes, you get the IP only from ARM. For RISCv, there are many vendors. You can buy the processor IPs from various vendors. Can you think of adding your own instructions? For x86, no. For ARM, no. For RISCv, yes. Are there any open source IPs? You don't want to pay for it. You just want to use open source IPs. For x86, no. For ARM, no. For RISCv, yes, there are many IPs available. You can visit the RISCv website, riscv.org, and you can find out. RISCv adoption. RISCv ecosystem is growing fast. You can think of simulating RISCv ISA. There are various simulators available. There are various emulators available. And there are various boards available for the software development. Operating systems like Linux and Android support RISCv. RISCv will be in more than 16 billion SoCs by 2030. These are all some of the new processors implemented by companies like SiFi. These are all some of the new applications implemented by companies like Qualcomm. So RISCv is going to emerge as an industry standard ISA for all computing devices. CPUs, GPUs, DSP, accelerators. Is going to emerge as an industry standard ISA for all computing devices. CPUs, GPUs, DSP, accelerators, neural engines, for all kinds of processors. RISCv is going to become an industry standard ISA, instruction set architecture. So there will be more demand for RB128, RISCv 128 ISA in the future. There will be many new extensions, and there will be many new specialized processors using RISCv OpenISA. They are not going to use any proprietary ISAs in the future. Thank you.